Alright guys, so today the whole goal of this particular video is to help you get started on how to solve trig equations. Trig equations are just like any other mathematical equations. The algebra still stays the same. The only difference is that you now have trig functions showing up. So we're going to start slow, and then we're going to talk more a little bit as we go through as how can we approach these problems? What are some things that we can do? What are some strategies we can use? So it's kind of like using everything that we've done in the last two sections, plus a lot of the stuff that we did last unit. It's all coming together now. This is what it's all for. Okay, so I have a basic trig equation here. 2 times the sine of x equals 1. The goal, guys and gals, is to isolate the trig function by itself. So you want to get sine of x by itself. Well, this is a very straightforward one. We're going to divide by 2. And so if we divide this by 2 and divide 1 by 2, all of a sudden we now have the sine of x is equal to 1/2. Okay, so we have the sine of x is equal to 1/2. Well, now you're like, okay, this is very straightforward. You know how to solve this. Now, go back to where we have been before. Okay, we started out with the unit circle, and we decided, well, wait a minute. There's 2 places where the sign of a value is positive. Okay, and remember the sign is the y value, so it's basically when y is positive, x, or in 4 quadrants. When y is positive, then the sign is going to be positive, right? So where do we get a value of 1/2 between 0 and 2 pi? Now remember, all the way around it takes you from 0 all the way to 2 pi. Some of you seem to forget that on their last quizzes and tests and things like that, okay? So we have 0 to 2 pi. So most of the time we're going to limit it to this range, but I'm also going to show you in class when we don't limit it, what do we need to do, okay? So where is the sine of x equal to 1/2? Well, clearly it's at 30 degrees, but we want to do this in radians, guys, which is another reason why you should be more comfortable with radians. So in this case, x is going to equal pi over 6. But it's also going to equal 5 pi over 6, because remember, quadrant 2 also has a positive sign of 1/2. Now in quadrants 3 and 4, the sign is negative because the y value is negative and you're under the x-axis. So the simple answer for this simple equation is pi over 6 and 5 pi over 6. Those are the 2 places between 0 and 2 pi where you get a sine of x equal to 1/2. Okay, so now what? Well, now we just start talking about what are some different strategies, okay? Well, obviously, remember what we said that we want to do. We want to get the trig function by itself. So in this case, let's collect all the sine of x's on the left-hand side and get rid of that square root of 2 and move it to the other side, all right? So if I add the sine of x to the sine of x plus sine of x is 2 sine of x. Okay, and then I'm going to go ahead and leave that as the square root of 2 for right now, but we will move it in the next step. And we added the sine of x, and hopefully you realize this. This is just basic algebra again. So now let's go ahead and subtract that square root of 2. So we have 2 sine of x equals negative square root of 2. Okay? It is crucial that you keep your eye on positive and negatives because, again, we are looking for things in all 4 quadrants. Most of these are going to have 2 answers. They may not all have 2 answers, but most of them are going to have 2 answers. So we just got to be really, really careful. All right, so now we're going to divide by 2 to get rid of that 2. So again, we're trying to isolate the trig. function. And we get the square root of 2 over 2. And of course the negative is still there. Okay then, guys. Now we have to think. Where do we have the sine of x equals negative square root of 2 over 2? Well, this again is one of those wonderful little unit circle things that if you have your unit circle memorized, it'll be like, oh, wait a minute, it's this and this. Okay, you're thinking, I'm hoping you're thinking, oh, that's a 45-degree angle. Okay, but then this is a negative. So where is the sign negative in the 4 quadrants? Okay, because again, we're going to look from 0 to 2 pi. Okay. So in that point from 0 to 2 pi, the sign is negative in quadrants 3 and 4, just like we talked about in the last problem. So if they're negative in quadrants 3 and 4, what radian measurements, angles, represent 45 degrees? Well, if that's basically, it's 215 degrees and 315 degrees. But again, we like to do it in radians. So x is going to equal, remember, 45 degrees is pi over 4. In quadrant 2, it's 3 pi over 4. In quadrant 3, it's 5 pi over 4. And in quadrant 4, it's 7 pi over 4. Again, why do we have 2 answers? Because the sign has a value of negative root 2 over 2 in 2 different quadrants. Okay? We have nothing else that limits us. So here are our answers within one cycle. Remember, the sign has a period of 2 pi, right? So within that one rotation around, there are 2 places where the sine of x is equal to negative square root of 2 over 2. Okay. Well, let's keep going. Okay, so here's another typical problem. Notice that we have a squared trig function. That's going to become really important, and some of the things that I've told you previously, you're going to be like, oh, that's why he keeps harping on that. Yeah, it's why I do. Okay, but still the strategy remains the same. You're always going to try and start, whenever you can, to isolate the trig function by itself. So if we're going to do the isolation first, we're going to leave this 3 tangent squared of x. And we're going to add the 1, so now it equals 3 tangent squared of x equals 1. And then we're going to divide by 3. So again, we're not doing any difficult math right now. At least I hope it's not difficult. Okay? And now we have the tangent squared. Well, how do you get rid of something squared, guys? You take the square root. What happens when you take the square root? Well, on the left-hand side, you're just going to get the tangent of x, which is what you want. However, on the right-hand side, you must, and I repeat must, you have to remember that there is both a positive and a negative root here. So we want positive and negative square root of 1 over 3. Okay, this is where so many students mess up because they refuse to realize that there is both a positive and a negative root whenever you take a square root. Okay, so what do? Okay, first off, we have to remember that the tangent has a period of just pi. So now we are just looking for our interval to be within 0 to pi. Okay, and keep in mind that 0 and pi will not be necessary. Well, never mind. I won't say that at this point right now. Okay. So where let's simplify this, okay? So we get the tangent of x is equal to plus or minus the square root of 3 over 3. You know, I skipped a couple steps there. By now you should be able to simplify this to get to the square root of 3 over 3. Okay? So, where between 0 and pi, so basically we're just looking at the first two quadrants, right? Where do we have the square root of 3 over 3 as our tangent? Well, if you recall, that once again is our 30-degree angle, okay, from our handy-dandy unit circle. So how do I do 30 degrees? Well, that's pi over 6. And 5 pi over 6. And that's it, okay? Remember in general we just want one period's worth, okay? Sine and cosine have a period of 2 pi, so you have to go all the way around the circle. Tangent and cotangent only have a period of what? Pi. So you would not have to go all the way around the circle. All right, that becomes very important when we talk about general forms. Okay, so right now these are specific answers, right? We are coming up with two specific answers for this particular domain, because, and again, this domain is limited because that's the domain of the tangent. Okay. All right. Okay, so now we're going to step it up a little bit. All of a sudden, not only do we have not only do we have two different trig functions, we also have, you know, both trig functions on both sides. Okay, so whenever you're seeing something like this, one of the things you want to do is see if there might be any factoring that can be done. Okay, so again, let's try to get all the trig functions on the left hand side. So we're going to have cotangent of x times the cosine squared of x minus 2 cotangent of x equaling 0. Okay, now I notice that I have a common factor here. I have a common factor of cotangent. I have a factor of cotangent here and here. So I'm going to pull that common factor out and see what I have left. So I'm going to do the cotangent of x times cosine squared of x minus 2 is equal to 0. Okay? Well, now at least I have factors. Okay? Now I can say the cotangent of x equals 0. And I can also say, so I have an and here because the other possibilities are cosine squared of x minus 2 is equal to 0. Just like after you factor, you know, a normal polynomial, you do the exact same thing. You set each factor equal to 0. Okay? Well, the cotangent of x is equal to 0. Okay? There we're going to be looking for 0 to pi. Okay? So the cotangent of x equals 0, that's just simply pi over 2. That's where the cotangent is equal to 0, and that is between 0 and pi. Now the cosine, we got to do a little bit of work there. We get the cosine squared of x is equal to 2, which means that the cosine of x equals plus or minus the square root of 2. Okay? So remember, now this is interesting, okay? You need to remember that the range of the cotangent function is negative infinity to positive infinity, right? But what's the range of the sine and the cosine functions? Well, those ranges are just from 0 to 1. Remember, we're talking about the range. We're not talking about the domain. We're not talking about x values right now. We're talking about y values, okay? So what they're trying to say is if I take the cosine of x, I'm going to get a value of plus or minus the square root of 2. Well, guys, the square root of 2 is bigger than 1, right? So there is no solution here for plus or minus the square root of 2. No solution. There is no x value where you can take that angle and put it in and get plus or minus the square root of 2. It just doesn't work. Okay? The biggest you can get is 1. And the smallest you can get is negative 1. So that is outside the range, so there's no solution there. So the only solution to this problem between 0 and pi, and again I'm looking at between 0 and pi, is pi over 2. Okay. I hope that makes sense. This is tricky, okay? Especially this part right here. Once we had the cosine equaling something that was bigger or less than, or bigger than 1 or less than negative 1, there's no solution. Same thing if it had said sine, okay? So we need to try and, watch ourselves when we're doing these problems, okay? Okay, so here's a typical problem, another equation to solve. Notice that I have given you a specific interval here. I only want answers between 0 and 2 pi. Now, I have a sine squared, I have a sine, and I have a constant value. Everything's on the same side. Now, I could move the 1 over and try to factor that, but guys, if you have a square and a non-square and a constant, see if you can factor that. This factors very straightforwardly, okay? So this becomes 2 sine of x and we have sine of x. And then the 1s, there's only one thing you can do with that, right? Now I want a negative answer. Okay, so I'm going to put a negative there because it'll multiply by the 2 and a positive there. So again, we're still looking to factor. It's nice if we have a, the same trig functions. The next problem that we're going to do is going to be a problem without the same two trig functions, okay? All right, so now, just like you did with the last problem, we're going to set each of these 2 sine of x plus 1 equals 0, and sine of x minus 1 is equal to 0. So now we have 2 sine of x is equal to negative 1. So the sine of x equals negative 1/2. And we also have sine of x is equal to 1. Okay, this one should come, the first one should come very easily to you. Sine of x equals negative 1/2. Well, that's quadrants 3 and 4 of that pi over 6, right? So those answers are going to be 7 pi over 6 and 11 pi over 6. Okay, where does the sine of x equal 1? Hopefully you all got this rather easily. The sine of x equals 1 at pi over 2. Okay. So in between 0 and 2 pi, we have 3 solutions that would make this a true equation. Okay, x would be equal to 7 pi over 6, 11 pi over 6, and pi over 2. All right, as promised, we have something now in the same form, but with two different trig functions in it. Okay, now, ladies and gentlemen, the cosine function is going to be really, really difficult to get rid of by itself. But we do have a function or a identity that relates sine squared to cosine. Well, not directly to cosine, but to what? Cosine squared. Okay. Remember, sine squared plus cosine squared equals 1. So I'm just going to rewrite this as 2 times 1 minus the cosine squared. If you're not quite sure how we get the cosine squared, 1 minus cosine squared instead of 1 plus cosine squared, think about what I said. Sine squared plus cosine squared equals 1. If I want sine squared by itself, I have to subtract that cosine squared. Okay, so we have 3 cosine of x minus 3 equals 0. Let's do some multiplying and simplifying before we try to actually factor. So we've got 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. Okay. So let's do a little bit more math. We got negative 2 cosine squared of x plus 3 cosine of x minus 1 equals 0. I don't like this negative in front, so I'm going to multiply everything by negative 1. So I have 2 cosine squared of x minus 3 cosine of x plus 1 still equals 0. All right, now let's factor it. Again, guys, this should be an easy factor. You can only do two things. You got 2 cosine of x, and you got cosine of x. Okay, as you can see, I'd rather write and not talk at the same time. So I finished factoring. I got 2 cosine of x minus 1 times cosine of x minus 1, and now it's just back to what we know. So we get 2 cosine of x minus 1 equals 0. And we've got cosine of x minus 1 equals 0 again. So we get cosine of x equals 1/2, and the cosine of x equals 1. Okay, so now all we got to do is figure out where between 0 and 2 pi does the cosine equal 1/2, and where between 0 and 2 pi does the cosine equal positive 1. Okay, well, for the cosine to equal positive 1, that's easy. That's at x equals 0. And also at 2 pi, but we only have to put it down once. Okay, where does the cosine equal positive 1/2? Well, that's a 60-degree angle. Okay, so I know it's in quadrant 1. So I know that I have for this one, x equals pi over 3. Where else is the cosine positive? Oh, well, that's in quadrant 4. So what represents that 60-degree angle in quadrant 4? Well, that's my 5 pi over 3. And there we go. Pi over 3 and 5 pi over 3 are where the cosine of x equals 1/2. And x equals 0 is where the cosine equals 1. All three of those are your solutions. So again, the key here is to realize I can't get rid of the cosine in the middle. Let's see if I can change the sine squared into something that has cosine squared. Okay? One more type of problem. Okay, so here we go. Now we've got something where it's like, I have no idea what to do. I mean, there's no direct relationship between cosine and sine. Okay. All right, so since I don't have any direct correlation between cosine and sine, but I do have something that I can do with cosine squared and sine squared. Well, in order to get cosine squared and sine squared, I have to square both sides. So that's where I'm going to start. I'm going to square the left-hand side, and I'm going to square the right-hand side. All right, so cosine squared of x plus 1, please do not tell, or cosine of x plus 1 squared, please do not tell me it is cosine squared of x plus 1. Because remember, this is a binomial. Binomial squared will always give you 3 terms. So we have cosine of x, cosine squared of x, plus 2 cosine of x. At this point, you shouldn't be asking me where that came from. You should not be, not in this course. Plus 1 equals sine squared of x. Okay. Well, now I have something that I can do. Okay. I'm going to, since I have lots of cosines over here and I still have this cosine by itself, but I have a sine squared, I have a relationship between sine squared and cosine squared. So I'm going to change the sine squared into 1 minus cosine squared, just like we did in the last problem. So I have cosine squared x plus 2 cosine of x plus 1 equals 1 minus sine squared x. I'm sorry. I started writing sine, didn't I? Cosine squared x. Okay, so now everything's in terms of cosine. So now let's get everything to the left-hand side and see what we've got. So if I add cosine squared to this, I get 2 cosine squared. And I still got plus 2 cosine of x. But my 1's are going to cancel out, so I'm just going to end up with 0. Okay, well this is nice because it kind of factors pretty nicely. I have a greatest common factor of 2 cosine of x. So I've got 2 cosine of x times cosine of x plus 1. Again, I just pulled out the greatest common factor between these two terms. Okay, so now let's set each of these equal to 0. So I have 2 cosine of x equals 0. And I have cosine of x equals 0, plus 1 equals 0. Well, this is going to turn into cosine of x equals 0. And this is going to turn into cosine of x equals negative 1. Okay. Remember, we're looking for between 0 and 2 pi. So here are my possibilities. Okay. Where does the cosine of x equal 0 between 0 and 2 pi? Well, at pi over 2, for sure. And also at 3 pi over 2. Okay. Now what about negative 1? Where does it equal negative 1? Hopefully you realize that it's equal at pi. Okay. And normally there we are. There we're done. Okay. But what did we do at the very beginning of this problem? Okay. We had to square both sides. Okay. Guys, squaring and taking the square root of any type of function means that you have to be really, really careful. When you take the square root, you have to realize there are both positive and negative square roots. When you square a function like this, a trig function, you may be putting extraneous solutions into your problem, okay? So whenever you square, okay, you need to write this down in your notes. Whenever you square, check for extraneous solutions at the end, okay? And we're going to do that here in just a second. Okay, so all I've done is I've taken our 3 possible solutions and written them down, and I went back and got the original problem, because the original problem is what we want to check. All right, so let's try it out. Let's do cosine of pi. Let's do pi over 2 first. So the cosine of pi over 2 plus 1 should equal the sine of pi over 2. Well, the cosine of pi over 2 is 0, so I have 0 plus 1. The sine of pi over 2 is 1, so I've got 1 equals 1. Okay, so pi over 2 works, so that's a good solution. Okay, so let's try 3 pi over 2. The cosine of 3 pi over 2 plus 1 is supposed to equal the sine of 3 pi over 2. Well, the cosine of 3 pi over 2 is 0 plus 1. But what's the sine of 3 pi over 2? It's not 1. It's actually negative 1 because you went down. So that's negative 1. So does 1 equal negative 1? No. So 3 pi over 2 is a bad solution. So I'm going to cross through it. I'll put a little check over here under this instead. All right, so we got one more. We've got the cosine. I shouldn't say it's a bad solution. It's actually an extraneous solution. And it came about because we did that squaring, because negative 1 squared is what? It's positive 1, right? So it thought it was going to work, but it isn't. Okay, so what's the cosine of pi? Well, the cosine of pi, that's negative 1. And then I add 1, okay? What's the sine of pi? Well, that's 0, okay? Again, knowing your unit circle really helps. I hope you understand that. Negative 1 plus 1 is 0. 0 does indeed equal 0. So pi is a good answer. So our only 2 true answers are x equals pi over 2 and pi. So guys, when do you check for extraneous solutions? Only when you actually squared the function, okay? When you put that squaring in there, that's when you are adding extraneous solutions. If you don't have to square it, if you're just using identities or changing things around, there's no point in checking for extraneous solutions because it's going to be right. Okay? Don't forget, if you take the square root of something, it has both positive and negative roots. You know, I keep harping on that over and over and over, and I hope you're understanding why now. Okay? It's really important because you have more than one solution in these general in these specific targeted ranges. Okay, so how do we identify just general solutions? And guys, I noticed on your test that several of you wrote your answers this way. So that's telling me that you're actually cheating because you're finding things off the internet to answer these questions. And I didn't appreciate it. I'll talk more about that when I make the video for the test that you all took. But that tells me that you looked stuff up and to try and get your answers, and it's just like, that's not right, guys. It's not right. It's wrong. You're cheating. Stop. Just stop. Okay? I'm not an idiot, despite what you may think. So, we said that at the very beginning, at the very first problem, that the sine of x is equal to 1/2. We said, well, we got an answer of pi over 6 and 5 pi over 6. And that was in a specific domain of 0 to 2 pi. But guys, these are infinite solutions, right? So that means that if I were to go all the way around the circle to a coterminal angle, wouldn't that be a solution as well? Okay, So if I were to add 2 pi to this, okay, if I were to add 2 pi to that, that would be what? That would be 13 pi over 6. That's a solution, okay? It doesn't happen to be between 0 and 2 pi, okay? But this is a general solution, okay? So what about 5 pi over 6? Again, if I go 2 pi more, I come right back to the same place, don't I? So I'm going to add 2 pi to this as well. But by adding 2 pi, all I did was go around one time, right? How many different, how many times can I go around? Okay? I can go around as many as I want to, okay? I can go around infinite number of times. So what I have to do is I have to put a counter in here, and that counter is going to be n, okay? So if I go around one time, then n is 1. Okay, so I have pi over 6 plus 2 pi. Okay, that would give me my 13 pi over 6. If I don't go around at all, the counter is 0. So then I would just have pi over 6, right? What if I want to go around backwards? Well, that's fine too. If I put in -1, I'd do pi over 6 minus 2 pi. Then I'd have a negative answer, wouldn't I? Okay? But I have to identify the fact that n, or what n is, okay? So I just have to identify that n is an integer. Okay? The fact that n is an integer takes care of all the negative. I can go to negative infinity counting by ones. I can go to positive infinity counting by ones. But I have to write this. Okay, so those of you that gave me answers in this form on your test, first off, like I said, we hadn't even talked about this. And second off, you never even told me that n was an integer. Okay, so you didn't know what you were talking about. So, like I said, just stop. Okay? Maybe come to class, maybe pay attention, and maybe come to office hours if you need help. Because when I saw those, I was just like, I was furious. I was absolutely furious. There's no reason for that. Okay. So, but now is when when it gets used. If we want a general solution, not a specific one, not in a specific limited domain, then we need to add the 2 pi n, and we need to indicate that n is an integer. Okay? So, with that being said, I think that's enough for today. I'm hoping that you guys get a chance to watch this. And I want you to try your other 6 problems. Or, I'm sorry, other 12 problems that are on that homework from Monday. Okay, I know you turned in the first 6 now. 7 through 18 is what we're going to be working on. And that's what I want to look at in class tomorrow also. All right, guys, have a great day, and I'll see you tomorrow.